Alright, the next thing we're going to do is the sampling distribution for the difference between two sample proportions. Alright, essentially the same thing as we've done above for averages, but we're going to do it for proportions now. Alright, so we'd have our two groups. Alright, both groups will have their own true population proportion. We'll have sample data N1 and N2 again, and we'll have sample proportions p hat 1 and p hat 2. The limit of the normal distribution that we're going to look at or use is p1 hat minus p2 hat. All right. In other words, the distribution is the distribution of those differences between the two proportions. The mean of the distribution is P1 minus P2, that is the true average of the normal distribution. The standard deviation of the normal distribution is sigma with a subscript P hat 1 minus P hat 2, and that equals the square root of P1 times 1 minus P1 on N1 plus P2 times 1 minus P2 on N2. Alright, again, different formulas, but all the same sort of concepts. Okay, but now we deal with proportions, so you don't have to be given a standard deviation. We calculate standard deviations on the fly. Okay. Alright, what else do we need to do here before we go on to do a problem? Nothing more. Alright. Okay, so let's look at one of these problems. Alright, wrong page. Alright, it's this one. Top problem here. Last year, 78% of 120 UAB students taking the CPA exam passed. This is all fictitious information, by the way. This year, 91% of 85 students passed. Assuming that the true pass rate was unchanged at 80%, right? What is the probability of getting an increase as large or larger? Again, just like the averages problem, a lot of students, since we're talking about increase this case, right? Not like the last example in averages change. This is an increase, so it's one of the tails, not two. Since we're talking about an increase, it might be nicer to have the larger proportion first. So we'll do this year versus last year. Alright, so this year 91% of 85 students passed. So this year P1 hat is 0.91 on 85 students, so N1, sorry, 85 students. And P hat 2, 78% of 120 students, so that's 0.78 with N2 of 120 students. So our limit is P1 hat minus P2 hat. It's 0.91 minus 0.78. What's that? 0.13, 13% increase. What we'll need now is P1 minus P2, the mean of the distribution. Alright, assuming the true pass rate remained unchanged at 80%, so 0.8 minus 0.8 is 0, and then the standard deviation for proportions were not given, we calculated, so that's sigma, so p hat 1 minus p hat 2, square root of p1 times 1 minus p1 on n1 plus p2 times 1 minus p2 on n2. Sometimes in your notes you'll see p1 times q1, right? In all proportions problems, q is 1 minus p, the complement. Okay, so don't ever get too disturbed by that. Alright, so back to our standard deviation. P1 is 0.8 times its complement, 1 minus p or q, 0.2 divided by the sample size of 85, and P2 again is 0.8 complement 0.2 divided by sample size of 120. Okay, and do that problem. Let's go to Excel to do that calculation. Equals the square root of 0.8 times 0.2 divided by 85. Let's go back and check my numbers. Alright. Plus 0.8 times 0.2 divided by sample size n2 of 120. And so the answer to that is 0.5671 to 4 significant places, so 0.5671. Alright, so then we have a limit, 0.13, a mean of 0, and standard deviation, 0.05671. Let's draw a diagram. This is the, sorry, it's a stray character in there. This is the distribution of the difference in the sample proportions, right? It's the distribution of all differences, such differences. The mean of that distribution in this case is 0. The limit, right, 0.13 and up. Right, it's probability of getting an increase is larger or larger, and we have a standard deviation. Alright, we translate that to the z distribution, and again it's the area in a tail. Alright, so what we're left with here is to write down that statement. Alright, this is the probability of getting a sample proportion difference greater than or equal to 0.13, where, oops, sorry, it's a little bit heavy. The mean of the distribution is 0. Standard deviation of the distribution, sigma sub p hat 1 minus p hat 2, is equal to, I've forgotten the value already, 0.5671. Alright, and we're going to change this into the probability of getting a z greater than whatever. Okay, so we have to calculate that limit in terms of a z. So it's a sample difference limit minus the true population difference divided by the standard deviation. Alright, the limit 0.13, the mean 0, divided by the standard deviation 0.5671. Let's go to Excel and figure that out. So that's 0.13 minus 0 divided by standard deviation. It's to 2 decimal places, 2.29. Okay, we always go to 2 decimal places on the z because that's the best our tables give us. Alright, so again, it's an area in the tail, so or half minus the value from the table from 0 to 2.29. Alright, 2.29 will be that value over here, 0.4890. And the answer to that, doing it quickly in my head, is 0.110. Alright, just a little bit greater than 1%.